Hello, everyone. This is Team Gridiron building a sustainable smart irrigation system, and welcome to our poster presentation. Our group obtained an industrial project with the Everly Hotel in Putrajaya, which has a wall fitted with potted plants located around 100 meters away from the hotel, which they named the Green Wall. Their greenkeeper has to travel to the wall to manually inspect the plant's soil condition and manually water them twice a day. This leads to suboptimal usage of water, especially when the soil moisture condition is not apparent. And also, while watering plants at hard to reach areas, such as on the top of the wall, leads to water wastage. Therefore, the hotel has requested for a smart and automated irrigation system for the green wall. Our group's proposed system aims to reduce the usage of water on the green wall by controlling the water sprinkler automatically using clean energy. The objectives of our project are as shown, and they are: 1. To develop an automatic water sprinkling system. Number 2. To build a self-sustainable system using solar energy. Number 3. To integrate the system with IoT with a GUI for system visualization and remote control. Number 4. To construct a communication protocol between system and user. And number 5. To formulate scaling potentials on advanced farming technology. The completion of our project will provide an automated water management system for irrigation, saving both water and labor. The GUI would enable remote and real-time monitoring of the green wall, such as the soil moisture condition, the water usage, and the battery charge at the green wall. It will also enable the user to remotely control the water sprinklers, which is a feature specifically requested by the hotel. Lastly, since a reliable electrical infrastructure is lacking at the green wall, our project furnishes it with electrical power derived from renewable energy. That's all from me. Thank you.
My name is Jack. So before this, Jerome already explained to us our aims and objectives. Now I'll explain how are we going to achieve these objectives through a certain type of methods. Here is the overall system architecture through a full block diagram of our system. But in order to avoid complex explanation, we will go through a more simplified diagram. It shows that we have sensor nodes and actuator nodes, so we can control the water sprinklers through this GUI. We have a few pictures showing the front view of the green wall and the rear view of the green wall. We install the 4 solar panels on top of the green wall and our control panel, the back side of the green wall. Now we start from the solar panel. Once the solar panel charge the battery will provide power to the MPPT charge controller, and MPPT charge controller will give us a load to our main control system. Now, based on the green arrow we can see on top of here, it provides us the power for all the power regulators. Now, the power regulators regulates our voltages into specific voltage to be used by the Arduino, the relays, and the sensor. The power voltage are 12 volts and 7 volts. Now, we have also a few pictures on our left-hand side showing the moisture sensor and the water flow sensor. It provides data to our second Arduino microcontroller, which is placed at the bottom side of the control box. Now we have solenoid valves, which is controlling the water pump, and these two AC water pump are the actuators of our system. It's connected at the bottom side of the terminal box. Now we have relays, and these relays control the AC pump, the solenoid valve. Now we also have a separate relays for the AC pump, specifically because the AC, to separate it from the AC and the DC power. We have another second microcontroller, Arduino Omega, and we zoom in a little bit, and this is actually our LoRa antenna 1. So LoRa antenna will be connected to our second antenna, which you can see a yellow arrow, and this yellow arrow represents a duplex communication between both Arduino. It collects the sensor data and is sent to this microcontroller, and then this microcontroller will send the data to our second LoRa antenna. Now the second LoRa antenna will communicate with the MQTT server. MQTT server will provide our data to our GUI. So this is the whole communication bridge, and we can actually see through the GUI, we can show the water level, we can know what is happening on the moisture data through the MQTT data server. And if the user wants to control, it can go through back the LoRa engine and go through back the same procedure. Thank you.
Hello, my name is Srivan and I will be presenting now. This is a demonstration of our system. The system is turned on by switching on the solar charge controller and the circuit breakers. On the GUI, we select the moisture readings tab. Here we can view the soil moisture percentage from the moisture sensors of the board. On the sprinkler tab, we can manually control the valves for the sprinklers individually or all at once. The corresponding relays will be turned on by clicking the send button, which will open the corresponding solenoid valves to allow water to flow. After turning on all the valves, we can see each of the rows of sprinklers that waters the plants via a drip system. The drip system was used to ensure there will be no wastage of water. This also gives time for the moisture sensor to update values to the GUI. This is for the manual control of our system. To automatically control the system, the user can set the threshold values and the settings for it on the Settings tab. By analyzing the graph, we can conclude that the proposed system consumes lesser water when compared to manually watering using a hose. These results, however, do not consider the raining period. That's all from me. Thank you.
Good afternoon. My name is Iyad Ali, and I'll be presenting the innovative features of our project, which is smart irrigation system. Even though our project has innovative features such as long-range communication using LoRa network, the main innovative feature of the project is called dynamic automation of sprinklers. So what I mean by dynamic automation is settings such as irrigation schedule, sprinkler on time, moisture threshold of the system. Those settings can be changed dynamically without changing the code of the Arduino boards or the TTGO boards. So this feature is very useful because let's say for an example, a gardener wants to change the settings of the irrigation system. He or she can change the settings from the dashboard itself without needing an engineer or technical staff to upload the code again to the Arduino board. So in the next slide, I'll show a demonstration of how I can change the settings using the. So the next component of the project I'll be explaining is the sustainability. So our project is very sustainable because we are fully powering it by using 4 solar panels that produces approximately about 2 kilowatt hour per day. So it has a very low carbon footprint because no fossil fuels were burned for electricity. Also, the water consumption by our irrigation system is kept at a minimum. So this is a picture of the 4 solar panels we have installed at the green wall. Also, for our project, we were able to accomplish 5 of the 17 goals, 5 of the 17 sustainable goals. Those goals include clean water and sanitation, affordable and clean energy, sustainable cities and communities, responsible consumption and production, climate action, and at last, life on land. The next is the marketability of our project. So the total cost of the project is 5,355 ringgits. So it can be divided into solar panels, which is the biggest expense. So those includes the inverters, the wires, the battery we use to power the whole thing. Next biggest expense is the sensors and the actuators, and the smallest expense is the communication network. So to conclude, most of our objectives were fulfilled, which includes the visualization of the sensor readings and remote and automated control of the sprinklers. Limitation of our current system include the current sprinkler system is not integrated with the weather focused data. So if it is raining today and if the system is scheduled to water the plants at 6 p.m., it will still water the plants. So that is a possible improvement that can be brought to the system. So that's all from Team Gridiron. Thank you.